Okay, so this is going to be the solution to the 19th problem in the grind 75. This one is called reverse linked list. And as the name implies, we're going to be taking a singly linked list, like this one right here, and reversing it. So I think a better way to think of this, rather than flipping all the nodes over like this, is to just think of how we would flip all the pointers. So really what we need to do is make 2's next pointer point to 1 and 3 to 2 all the way to 5. And also another key thing is in linked lists, nodes at the very end, like 5 for example, they do have a next pointer, but they point to null. So when we reverse this linked list, we're going to need the first node to also have a null pointer, or a next value equal to null. So I'm going to switch over to the drawing board so we can visualize what should go on. So this is that linked list from that example. I'm actually going to make a node out here, just put a slash through it. That's going to represent null. And we are given the head of the linked list. So it's going to be right here. And the way to reverse a linked list is to add 2 more pointers so we can hold on to the appropriate values when we're switching next pointers. So we're going to need, we can call this a previous value. Maybe we can call it back, and we'll call this one front. And this is going to be head. This is back. This is front. Okay. So if we think about what needs to be done, we're actually going to start off like this. Front's going to point here, and then we're going to move the front pointer on to heads next, right there. And we're going to have head take its current next pointer and point it back to null, like this. And this is going to point to null. And then from there, we can move on by taking the head pointer and putting it to front, like this. And then we're going to, so actually I did that in the wrong order. First, we're going to have to take the back pointer, put that to where head currently is. It's going to be right there. And then we can take head and move it to where the front pointer is. So basically, anytime we want to move something somewhere or change where something is pointing to, we need to have a pointer already in that location in order to access it. That makes perfect sense. So that's why we have to have 3 pointers in total, because we need something that can move us on, then we need something that can refer to a node back here, even though we have no direct link to it. And then we need a way to update our back to this newest value, and then have a way for head to go up to, say this new front value once we don't have this pointer anymore, once this pointer is pointing over here. So that's why we have to have these pointers in strategic locations and move them at the appropriate time in order to successfully reverse the linked list. And once we understand the physical intuition behind that, the actual implementation is very easy. So let's switch over to that. So the first thing we're going to do, because of this possible case right here, we can have a linked list with 0 nodes in it. So I'm going to say if head is equal to null, then we are going to return null. Otherwise, we're going to say while head does not equal null, we're going to do what we said we were going to do. So first off, we're going to have to make the pointers. We can make a list node pointer called back. We'll set that equal to null initially. And we can just instantiate a front pointer right now. So the first thing we want to do is we want to move the front pointer up. So we're going to set front equal to head.next. Then we're going to want to take head's next value, its pointer, and point it to where previous is. Then we're going to want to push the previous pointer up to where head is, and then push head up to where front is. And this is all there is to it. In the end, we'll have to return previous, and I will actually illustrate that really quick. So we're going to flip over to Paint really quick, and I am going to change up the illustration, and just give me 1 second. All right, so say we followed the algorithm to this point where we have head at 5 and front at 5, and then previous would be back here. So we're going to say while head does not equal null, we're going to continue the algorithm. So we can move this front pointer on because this is technically pointing to a null node. So again, following the algorithm, we'll start by moving the front pointer on, changing head's pointer, which is this one, to where back is pointing to. That's going to point here. And then just running through the rest of the algorithm, the back pointer is going to move on to where head is. And then, then head is going to move on to where front is. And because head is null at this point, we can't return head. We'll have to return null. And that is the explanation for why we have to return previous, which we should actually refer to as back, the back pointer, instead of the head pointer. And let's just run to make sure we have no small issues. We do. List node back. Let's see. Previous is equal to head. Yeah. It should be called back. Okay. That passes, so then we should pass pretty much every other case. And yep, that has been the solution to the 19th problem now in the grind 75. This has been reverse linked list.